Welcome to Improve Database Performance with Azure Database for MySQL Flexible Server. This session is presented by me, Siddhant Sawant, Senior PM for Azure Database MySQL in MariaDB, along with my peer, Bashar Hussein, who's also Senior PM for Azure Database MySQL MariaDB. So let's get started. Today we'll discuss the deployment options we have for Azure Database for MySQL, and then we'll discuss about why we should choose flexible server and also discuss the flexible server architecture at length. And then we'll look into the factors which affects the performance of flexible server. Then we'll look into the workload right sizing, which workload suits which tier of a SKU. And then we'll look into business critical service tier, followed by some of the demos. So let's start with deployment options. Deployment options, when you go into deployment for Azure Database for MySQL, you see two options, single server and flexible server. Single server is our initial offering, which was GA back in 2018. And it is recommended for the customers who are already using that. But the newer deployment should be on flexible server is what we recommend right now. Flexible server is fully managed production ready database service designed for tier 1 workload, providing more flexibility and granular control on the functions and the configuration settings. So it's the better version of the deployment with better HA as well. Having said that, our offerings are based on the following aspects: high availability, elastic scaling, intelligent performance, industry-leading security and compliance, and the integration with Azure ecosystem, which helps you to build your application robustly in the Azure ecosystem. Let's move ahead and we'll discuss why you should choose flexible server. Based on our learnings from the single server, when we GA back in 2018, there were some challenges which we faced. The important one was the latency. The latency because there was limited control on the placement of resources for single server. Gateway for single server and the database itself was not in the same AZ, the same regions, which caused extra hop due to the gateway in between. That problem was solved in the flexible server by AZ co-location and no gateways, which resulted in better latency compared to single server. Connections. Decoupling of connections was done in flexible server. In single server, the connections were coupled with the vCores or the compute. If you needed more connections to your database server, you have to spin up a new server or upscale the server to a higher SKU. That does not happen in flexible server. The higher tier of flexible server can accept up to 86,000 connections. The connection string in single server required server name as a part of username, which was really cumbersome and not a good experience for the end users. So that was also changed in flexible server. Another challenge was the maintenance window with the single server. The maintenance window spanned up to 15 hours in single server, although the downtime was not 15 hours or in hours. The downtime was the patching, the patch management or deployment takes few seconds or minutes behind, but it can happen in the 15 hours window and the customer would not have any flexibility in choosing the maintenance window. But in flexible server, the customer can choose the maintenance window of 1 hour and then can get the patch management or security fixes done in the maintenance window of their choice. Resiliency with zone redundant HA is also possible in flexible server. And single server was deployed in Windows, or with the architecture beneath the single server is Windows based, but the flexible server is Linux based deployment. The architecture beneath is based on Linux, which helps bring out the best in the MySQL servers. Native network isolation. Deploying flexible server into Azure VNet provides private and secure network communications. That's more important to have private and secure connections. So that is possible with flexible server. Let's talk about flexible server architecture. Flexible server architecture is very similar to having MySQL on VM. It's very similar to installation of your MySQL when you do it on your VM. But in flexible server, the compute and storage is decoupled. Data and log files are stored in Azure Premium Storage, which maintains 3 copies of data. As the compute and the data storage is decoupled, it becomes easier to manage them. And if the compute goes away, another compute is deployed and attached to the storage underneath. If any disk corruption happens, one of the 3 copies or the other 2 copies are used to retrieve data from the disk or from the premium storage. Locally redundant backups are also maintained on PFS share, which helps you to have better backups and easier access to the backups. And also we maintain redundancy in the backups in case of deletion or disk corruption. We also have better HA with flexible server, and we'll discuss that in the next slide. Flexible server architecture, zone redundant HA. As you can see in this slide, you can see 2 servers. One is primary and the other is standby. In a flexible server, when you enable HA, you get this architecture. You get 2 servers. The one is primary and the other is standby. But this server acts as a single entity. By single entity, I mean if the primary server goes down, the automatic failover process takes over and standby server is promoted as the primary. But the application or the end user client would not know that the failover has happened on the flexible server, that the standby is promoted as the new primary. That is what I mean by a single entity. Connections did not change any connection string. They will have to connect to the same server. The only thing is the connections, if the connection has retry policy, it's well and good for the connections to reach the primary server again without any changes to the connections. It gives you more resiliency, and the automatic failover is easier with flexible server. As you can see, flexible server, the primary has its own compute. Primary server has its own premium storage. Similarly, the standby server also has its own compute and its own premium storage. In the image, you can see once the application coming it from the VM or the AKS or the application service, once connects to the Linux VM, or you can see the flexible server, it starts writing its data on the flush on its premium storage. Once it is flushed to the data is flushed to the storage we need. The process of copying the storage from the primary storage to the standby storage is synchronous. As soon as the data is written on the primary storage, it is copied to the premium storage. By data, I mean the binary logs which are written on the primary storage are copied to the premium storage of standby server. Binary logs are the logs written by MySQL, which has data and is responsible for replication in MySQL. So those bin logs, once written on primary, are copied synchronously to the data storage of flexible server standby. Once the standby node gets those bin log, the compute of standby server reads those bin log and starts applying those queries and the datas from the bin log to its own file in the premium storage of the standby server. That process is asynchronous. The copying of binary log is synchronous, but applying of those logs, applying of those queries is asynchronous. That is why we call this whole process semi-synchronous replication. So data, as soon as it is written on primary, is copied to your secondary storage, which is the standby storage, but application of that is asynchronous, which is done by the Linux compute on the standby server. That is how we make sure that we maintain copies of data on both primary and standby server. In the failure scenarios, or in the cases of failure, to detect those failures, backend will always try to ping the compute and the query engine. Query engine is queried for the queries all the time to detect any kind of failure. If the ping or the query fails from the backend, the failover process is started. Once the failover process is started, it again checks for if the compute is away or the query engine has failed or not. If they get a success in that process, they abort the failover and stay with the current primary server only. If again the compute is unreachable or the query engine is unreachable from the backend, the Linux VMs, the failover process is started. The failover process, as I explained before, the standby server takes the place of primary server, and then the DNS entries are also changed, and the application has to not connect to any other endpoint as well. So that's how we maintain HA for flexible server. The daily data backups are also zone redundant, which helps you to maintain backups in zone redundant storage. So if you have any questions about flexible server architecture, we'll discuss it at the end of the session. Let's move ahead. We'll discuss the factors influencing the database performance, or the database performance influences with flexible server. We'll discuss 6 points here: physical proximity, server parameter optimization, connecting efficiently, query and table optimization, right sizing your workload, and business critical skew. Physical proximity, as the name suggests, it's very simple. Deploying your application or client services in the same region as that of your flexible server. The turnaround time from the client to the database and the database giving the expected result back to the client is very small in terms of physical proximity, where you deploy your application in the same region as that of your database. Also, when you create the VMs for your application, or you were or any kind of functions or processes which run, if accelerated networking is used, the performance benefits are as shown. If you see the average latency, when accelerated network is enabled, it's 0.76, and when it's not, it's 1.1, which is a drastic change when you enable accelerated networking. So it is recommended to use accelerated networking, which helps in your faster retrieval of data. Let's go to the next point: server parameter optimization. Server parameter optimization is like the server parameters for flexible server are configured with default and recommended value when you create the server. You don't have to worry about the configuration file when you deploy your flexible server. Flexible server comes with recommended value and the default values while you start your flexible server deployment. So you need not worry which server, what parameters to take care when you start your server. So once you start your server, there are a few parameters we should look into when you're working with production and tier one workload for flexible server. With flexible server, we have InnoDB as default storage engine. InnoDB is so MySQL basically has a pluggable storage engine, and InnoDB is the best storage engine with ACID compliance and MVCC possible as well, or MVCC compliant as well. Talking about one of the important parameters for InnoDB storage engine is InnoDB buffer pool size. As the name suggests, the InnoDB buffer pool size is the size in bytes of the buffer pool, the memory area where InnoDB caches table and indexes data. It is as simple as saying that you maintain your data in your memory, and retrieving your data from your memory is always faster than retrieving your data from the disk. So InnoDB buffer pool is like a cache which you maintain for your database. So it is recommended to have 60 to 70% of the total memory size which you have on your flexible server deployment. But as you go higher, the skew, it is also okay to go above 70% as well if you have more memory to spare for your buffer pool. It's always to keep more cache to retrieve the data faster. Although we have to make sure that the max connections or the connections you make to a database are not too high. The max connections are the connections made to the flexible server will also draw some of the memory from your flexible server. So you have to make sure that you maintain a connection or connection pools, which we'll be talking about in the next slide, are also optimum in terms of memory. InnoDB buffer pool size is one of the important parameter and should be tuned when you're using flexible server for your production workload. InnoDB file per table. InnoDB file per table is like it creates its own file for every table. So every table gets its own file, its own management. So it becomes easier for every table to be optimized and managed, and it segregates your system table space and your in your tables, the user created tables. So the optimization does not interfere with system table space, and you do not corrupt the system table space as well. So it is highly recommended to have that. Always should be set on for better performance. Query cache type and query cache size. Although setting, as many of you would argue that having query cache is important for MySQL or any kind of database. Query cache caches your query and also the data as well. But setting the query cache type in MySQL has its own challenges, because every time the query goes for retrieval of data, it checks in the query cache, and that adds to the contention of the compute. That adds to the contention of the MySQL process. So it has to check every time for every query into the query cache, and then go ahead into the buffer pool, and then go ahead to the disk and retrieve the data back. So it adds additional overhead rather than helping your server. So it is recommended to disable both of these parameters, query cache size and query cache type, which will help you to have better performance. If not, the memory allocation will also go down if you disable these two parameters. InnoDB log file size, the size in bytes of each log file in a log group. So it is called as the redo log in MySQL. By redo log, I mean, or we can call it as write ahead logs or the val logs, which is quite important for your sequential writes or your crash recovery. So database redo logs is quite important in RDBMS, where sequentially data is written instead of arbitrarily writing to the table files. So inaudible log file size is quite important, as depending on your workload, the size of this log file is important. It can be changed as well. You can go up to 2 GB maximum in the flexible server, and as a recommendation, it should hold a data worth enough of an hour roughly. So if you can store that much of data in your log file, it's well and good for your flexible server. Although the inaudible log file size is a circular kind of file and it comes in groups, there's another parameter called inaudible log file size in groups. So you maintain 2 copies of log file size, and then those are written circularly, and data is flushed and then reused in log file size. So mind you, it also takes the disk space on your data files. So the data files include the log files as well in flexible server. Moving ahead, next point we'll discuss is connection or connecting efficiently. Long-lived connections are quite important in MySQL. MySQL opens up a thread in the MySQL process when you create when you connect to your database from a client. If you keep on opening new request or new thread for every connection, it will draw more and more memory from your flexible server. So it's best to reuse the existing connection rather than creating more new connections all the time. So making sure you have timeouts. The timeout is also an important server parameter when you connect to the client. So it can be client side and it can be server side the deployment as well. So having those timeouts set in server parameter is also quite important while connecting to your database. So it also helps you to maintain memory in MySQL flexible server. So it does, if you spawn more connection, it will increase your memory consumption as well. It is highly recommended to use connection pooling in flexible server because the lower latency per request, because you avoid connection process overhead. So the process of connection is avoided all the time. So that is why we recommend using connection pooling. There's a third-party tool called Proxy SQL, which is compatible with MySQL and MariaDB. It is a high-performant MySQL proxy. It is an application layer load balancer, basically. It understands SQL. It understands the SQL statements from the MySQL coming in, and then it can route the traffic as we tell it to do, as in if it will route the write traffic to the primary server, it will route the read traffic to the replica servers. In flexible server, we have an option of creating its own replica with ease. So proxy SQL can be used to route the traffic or load balance intelligently between primary and the replica servers and across different databases. So it also has inbuilt retry logic, which is quite important most of the times for application to connect and recheck whether the server is reachable or not, and can help you in various ways. It helps you to manage idle connections effectively, so you need not worry about connection pooling. Proxy SQL will do it for you in terms of connection management. For the next points and the further presentation, I'll hand over it to Bashar, and thank you from my end.
Hey, thanks, Siddhant, and this is Bashar. So switching now to another topic, which is right-sizing your workload with the Azure Database for MySQL Flexible Server. As you all know that regarding your workload, it's better to size your database service tier and the number of vCores, memory, all to perform better with your workload. Let's take a look at the Azure Database for MySQL Flexible Server different service tiers, starting with the burstable, general purpose, and compute service tiers. Each of those service tiers is better targeted to a certain kind of workload. Starting with the burstables queue, where it's best suited for workload that does not need the full CPU continuously. As you all know, there are some applications and workloads which require bursting of CPU, and this service tier is targeted towards those kinds of workloads. For instance, an office check-in, check-out application that does not require the full CPU all day long, but during business hours it will require CPU burstings. The number of vCores offered on this service tier varies from 1, 2, 4, 8, 12, 16, and even 20 vCores. The number of memory allocated per vCore is variable, and the storage size is anywhere between 20 gigabyte of storage all the way up to 16 terabyte. Switching to the general purpose service tier, which is targeted for most business workloads that required a balanced compute and memory with scalable I/O throughput. Throughput for this workload goes all the way up to 20,000 IOPS, and the number of vCores varies between 2, 4, 8, 16, 32, 48, and even 64 gigabyte. Now, if you look at the memory per vCore, it's 4 gigabyte per vCore. Taking an example is the 8 vCore service tier general purpose. It will have 32 gigabyte of memory. The storage size ranges between 20 gigabyte to 16 terabyte. Now let's take a look at the business critical service tier, which is ideal to run tier 1 production workload, which requires in-memory performance for a faster transaction processing and a higher concurrency. This service tier is, for instance, targeting real-time data, high-performance transactional or analytical applications. This service tier offers 2, 4, 8, 16, all the way up to 104 virtual cores. As you can see here, the difference between the general purpose and the business critical in terms of vCores, this business critical service tier supports 80 vCore, 96 vCore, and 104 vCore. Talking about the memory assigned per vCore, this service tier, the business critical, will have double the number of memory gigabyte memories compared to general purpose, so 8 gigabyte per vCore. Taking the same example, the 8 vCore you see here will get up to 64 gigabit of memory. The storage sizes ranges between 20 gigabyte and 100 terabyte. As you can see, the business critical queue is targeting the tier 1 service workload, which is scalable up to 100 terabytes. On top of that, the number of IOPS provisioned on the business critical SKU can go all the way up to 80,000 IOPS per second. Let's take a look at the architecture for the business critical SKU. As my peer Siddhant viewed the architecture for the burstable and the general purpose, obviously tier 1 workload will require revamping architecture to better influence lower latencies, higher throughput in terms of queries per second, auto I/O scaling, faster failover, and higher concurrency. I'll explain those while talking about this architecture. As you can see here, the database flexible server sits on top of VML, which is a virtual mid-tier layer. This mid-tier layer handles the storage layer in terms of writes and reads. So basically, bin logs and redo logs are saved on or stored on a premium managed disk, which is ZRS ready, the zone redundant services, and the bin log and relog are placed on this lower latency, fast throughput disk, which enables this service to have a faster failover and a lower latency in terms of fetching data from and writing data to disk. Now the data files will be saved on the premium file share, premium storages, and will be backed up as explained earlier by Siddhant. This business critical tier is best suited for running gaming, e-commerce, and internet scale application. And with this architecture, lower latency latency will be achieved thanks to the premium managed disk, low latency, auto I/O scaling. Basically, for this service, for the business critical SKU, the user will have two options regarding I/O. Either pre-provision IOPS, which means that you know your workload, you decided that your workload will require 40,000 IOPS at all time, so you will be pre-provisioning this 40,000 IOPS to best adequate or host your workloads. Now, there's another option where you have unpredictable workload or some kind of bursty hours, bursty times where you will need more IO. So you can opt in the auto IO scaling, which means that your provisioned IO will be scaled up and down automatically depending on your workload. So for instance, up until 8 a.m. in the morning, your workload required like 300 IOPS, which you will get all the time. At 8 a.m., your workload requires 70,000 IOPS, and the business critical service tier is intelligent enough that it will scale your IOPS all the way to 70,000 IOPS to serve your requests, and then we'll scale it back down at 9 a.m., for instance, when your IO requests will come down to 10,000 IOPS. This, for users, is a great chance to save on resources because better efficient and no need to pre-provision resources that will not be utilized. So this will have a higher utilization and lower cost in terms of input, output, and communication with disk. Now, the business critical service tier also offers fast failover and high concurrency. Failovers can range, we'll talk about them in the next slide, but ranges between 5 and 10 milliseconds. Now let's take a look at the business critical service tier. Now, no vendor lock-in. This will be purely community version of Azure Database for MySQL. You will be able to migrate to the Azure Database for MySQL Business Critical tier and take a copy and run it on your on-premises or different vendor of MySQL because this is compatible with the open source database. Scaling your workloads can go easily up to 104 vCores on the latest compute SKU and all the way up to 672 gigabyte of RAM. Auto scaling of storage, as explained before, goes all the way up to 80,000 IOPS. Fast failover in average between 30 and 60 seconds, and the promise with the latest minor and major version upgrades available every 6 months. So basically, every 6 months we'll push the latest minor version upgrade and we'll offer you the seamless migration tool to, for instance, now move between 5.7 to 8 with one click on the portal, and the automation from the back end will take care of the migration. We offer also migration worryless experience and a minimal downtime migration. Now, talking about the minor version upgrades, those will be taken care during the MMW, which is the monthly maintenance window. The monthly maintenance window will request you to choose 1 hour of maintenance. This 1 hour can be chosen any day of the month and any day of the week that you wish or that best align with your downtime. And during this 1 hour, there will be one restart for your server, which means that after the restart, your server will be running the latest version of the MySQL itself. And we will use this window also to patch your server for security, privacy, new features, bug fixes, etc. Now, the storage goes on the business critical SKU, as mentioned before, all the way up to 100 terabytes. Let's take a look at the business critical service tier benchmark. Let's see good numbers. Let's see how performant this service tier is. First, let's start by comparing the Azure Database for MySQL business critical performance over the single server. As you know, we will be measuring the performance for the databases in terms of throughput and latency. We're using Sysbench testing OLTP workload with 70% reads and 30% writes. Pretty typical workload that runs on the PaaS databases on the cloud. And we will be choosing the 16V core, which is the mid-tier in terms of performance. Now, as you can look here, the business critical SKU provide 1.5 times improved price performance over the Azure database for MySQL single server with the same vCore configuration. Remember, this is out of the box performance with no tuning was done. As you take a look at the graph here on the right hand side of the window, the queries per second are on the left hand side, the latency is on the right hand side, and at the x-axis is the number of threads. As you all know, when we increase the concurrency, the queries per second might drop. The bittersweet point is around 250 threads, and this service tier was able to achieve around 160k QPS. That's 160,000 queries per second compared to more than 80k. So it's a pretty significant improvement in terms of the concurrency and queries per second. Latency is significantly lower when we increase the number of threads. As you can see here, the 4,000 concurrent users, and we are talking about active concurrent users, no idle users, because if you're using the Sysbench, you are running 4,000 users which are executing queries, read writes against the database. And as you can see here, the single server was not able to keep up with this high number of concurrent active running users. Now let's take a look at the comparison with the AWS RDS, one of the rivals for the Azure database for MySQL flexible server. We ran same test, throughput, latency, Sysbench, testing OLTP workload with 70% reads and 30% writes on 16V core SKU. As you can see here, the business critical tier was able to provide 30 to 50% improved price performance over the AWS RDS for the same vCore configuration. Remember, this is out of the box performance testing. No tuning was done either on the MySQL side on Azure nor on the AWS RDS. As you can see here, with concurrency, both platforms acted differently, but the bottom line here is that the Azure database for MySQL flexible server business critical tier is better in handling lower number of concurrent users along with a higher number of current users. This new platform and the service tier, the business critical, can handle different workloads, different scenarios, and always will be able to perform better in both queries per second and latency. This is a great achievement. By the way, this test was run on a 5.7 version of the MySQL, 10 tables, and each table have 10 million rows. Now I'll play a video. This is a short video, 2 minutes, to show the Sysbench that we ran on MySQL and the one that we ran on the Amazon RDS. Enjoy. My name is Bashar Hussein, and I'm a Senior Program Manager in the Azure Database for MySQL team. Today we will be presenting Sysbench results comparing the new business critical service tier of Azure Database for MySQL Flexible Server versus AWS RDS. For the sake of this demo, we'll be using AWS RDS R5 X Large running MySQL 5.7 on 4 vCores and 32 gig of memory. Similarly, the business critical SKU is EVDS V5, 4 cores and 32 gig of memory, which is comparable configuration. Switching now to the Sysbench results, we're on 2 sets of OLTP 70% read, 30% write. Sysbench tests, one for 10 minutes and the other one is for 10 hours. Starting with the 10-minute results, RDS shows around 22,000 queries per second and average latency of 220 milliseconds. On the other hand, business critical SKU was able to complete double the number of queries per second of 37,000 queries per second with half the average latency. Thanks for all the innovation the product team put in place to improve out-of-the-box performance. Now let's take a look at the 10-hour suspense run. RDS average queries per second were around 21,000 queries per second and 220 milliseconds of average latency. The business critical SKU, on the other hand, was able again to run 2 times the queries per second at 37,000 queries per second with half the average latency. In conclusion, business critical tier is the flexible server premium performance tier positioned towards tier 1 customer workload, and as out-of-the-box suspense results suggested, we are finally have a service tier which beats RDS in terms of performance. Thanks for listening.
Thanks for listening for this demo. As you can see here that the really depending on the workload, the number of vCores that you're running, and the different workloads and the type of application that you need to use, business critical tiers comes to deliver the highest number of queries per second and the lowest latency. Thanks for all the innovation that was done on the business critical tier. We got a lot of feedback from customers who use the business critical tier. Very, very interesting, and we are proud for this achievement. We are working actually at the back end to improve this business critical tier much better in terms of price performance. This is our commitment to customers, that we always deliver a cutting edge technology which suits best for their workloads. Thanks again for listening in. This was delivered by Microsoft in the DPS 2022. We are working together for better data platforms, Geek and SQL Server Geeks, community initiatives. Thank you. There are 3 ways to win prizes. Post your selfie with the hashtag DPS 2022. Give session and conference feedback. Visit our sponsors and exhibitors. Follow Twitter handles, the Data Geeks and the Data Summit. Thank you for listening and have a good day. Now we'll open the floor for questions and any concerns you have. Thanks for choosing Azure Database for MySQL Flexible Server.